Good morning, students. So myself, Vijay Shankar from ECE Department, Chebur College. Today, I'll continue the remaining examples in the third unit of electrostatics. The example is the electric field intensity E bar. The electric field intensity E bar is negative gradient of scalar potential. Negative gradient of scalar potential. Find the E bar. See the gradient of E. The E bar is equal to minus del V. This is a formula for the gradient of V. Find the E bar, electric field intensity, at a point P 0, 1, 1, 1. If the A is given, the voltage is V is equal to, and the B is also given the V, but one is a Cartesian coordinate system, other one is a spherical coordinate system. In the Cartesian coordinate system, the del V, the E bar is equal to the formula we have, the minus of the V dou by dou x of AX bar plus dou V, let us say, dou V by dou Y of AY bar plus dou V by dou Z of AZ. So this is a formula for the gradient of V in the Cartesian system. The given function, the V having E naught is a common, and the e power minus x and the sine pi y by 4. There is many z term. So first of all, you can find the dou V by dou x. Dou V by dou x is equal to E naught is a constant. Sine pi y by 4 is also the constant, 4, and the e power minus x into minus 1. These are dou V by dou x. Similarly, the dou V by dou y is equal to E naught and e power minus x is a constant. And now we can apply for the sine. Sine is a cos pi by 4 multiplied with the pi by 4. And dou V by dou Z is equal to, there is no any Z term, for the constant derivative is a 0. Okay. Substitute these values at dou V by dou x and dou V by dou y is equal to in the E bar value. So E bar is equal to minus already there. And for the first one, minus E naught e power minus x sine pi by y by 4 into x. And the second term here, the e power E naught into e power minus x is a common, pi by 4 cos pi y by 4 into ay bar. Okay. We need a point at point 0, 1, 1, 1. So x is equal to 0, y is equal to 1, and z is equal to 1. So x is equal to 0, e power 0, the value is 1 here. And here also the e power 0, the value is 1. Sine pi, y is a 1, sine pi by 4. This total value is 1 by root 2. And here also the cos pi y by 4 is a 1 by root 2. 1 by root 2 is nothing but 1 by 1.414. That is equal to inverse is a 0.707. So the E naught minus into minus is a plus. E naught 0.707 into AX bar. And here already the minus is multiplied. So minus, so 0.707 into pi by 4. We get the 0.555 AY bar. Okay. For the next B, the given V is equal to E naught into R cos theta in the spherical coordinate system. First one is a Cartesian coordinates, and now it is a spherical coordinate system. What is the formula here? The dou V by dou R into AR bar plus 1 by r into dou v by dou theta and a theta bar, and the third one is 1 by r sine theta dou v by dou phi into a phi bar. So this totally minus value of E bar is equal to dou v by dou r. The given function, the r term and the theta term only, there is many phi terms. So the last bit always it's a 0. First of all, you can take it as a dou v by dou r is equal to E naught cos theta is constant and r derivative is a 1. And dou v by dou theta, E naught and r is a constant. And what is the sine theta? Sine theta value here, the derivative of cos theta. The derivative of cos theta is a sine theta. Okay, my dear students. I think it is a minus sine theta. Substitute this value in the E bar is equal to minus dou v by dou r we got is a E naught cos theta plus 1 by r into dou v by dou theta is a E naught r sine theta a theta bar, and here it is a ar bar, and plus 0 we got. So multiply this function with minus E bar is equal to minus E naught cos theta AR bar, and minus already here the minus is there. This total function is minus of because of minus sine theta for the derivative of cos theta. So minus into minus is a plus. R also get cancelled. E naught into sine theta a theta bar. Now we got the E bar is also. Again, substitute at the point of 0, 1, 1, 1 to the spherical coordinate system. Okay. One is first one, the quadrant is R, and second is a theta, and the last is a phi. But the given it is a XY coordinates. So XY coordinates is converted to the spherical coordinate system, means we know. So R, theta, and the phi are the coordinates of spherical coordinate system. But the given is a Cartesian coordinate system, means R is equal to under root of x square plus y square plus z square. So x square is a 0 and y square is a 1 and z square is a 1 and root 2. R is a root 2. So you can substitute the R here. There is any R term also. And theta is equal to. So what is the theta? Cos inverse z by r. R is under root of 2 and z is a value is a 1. So cos inverse 1 by root 2 means is a theta is a 45 degrees. Theta is a 45 degrees. So cos 45 means they take the minus g naught into cos 45 is 1 by root 2. Nothing but it is a 0.707 AR bar plus E naught into sine theta is also theta is pi by 4. Cos sine 5 to 45 degrees is 1 by root 2. Nothing but is a 0.707 A theta bar. Okay. So now you can see the E bar is equal to, you can take the E naught as a common. First term is a minus 707 AR bar plus second term is 0.707 A theta. Got it, my dear students? So it is a very important the formula to find the gradient of V or del V. Okay, E bar is how to find for the given V is equal to the potential is equal to. If suppose the point is given in the Cartesian coordinate system, convert to the spherical coordinates, or it is a cylindrical coordinate system also. Next example, an electric potential is given, V is equal to, and they are asking that is a find V and E bar at the point, directly they given 3 theta and the phi. The 3 is R is equal to 3, and theta is equal to 60 degrees, and the phi is equal to 25 degrees. V is given. So they are asking in the Cartesian, not the Cartesian, spherical coordinate system, E bar is equal to minus del V. We already know. The first one is a dou V by dou R. Dou V by dou R, you can find out 60 sine theta. 60 sine theta is a constant. 1 by R square. 1 by R square, it is a minus 2R power minus 2 minus 1. Okay. That is equal to minus 60, nothing but is a minus 120 sine theta by R cube. So minus 120 sine theta R cube is a dou V by dou R. Now let us take it as dou V by dou theta also. Dou V by dou theta means 60 by R square is a constant, and sine theta we get the cos theta. The derivative of sine theta is a cos theta, and cos theta is the derivative is a minus sine theta. Substitute this value, the last value is always given, it is a 0 only because there is no any phi term in the potential V given. So E bar is equal to, then substitute these values in the E bar at electric potential. E bar is equal to minus 20 sine theta R cube plus 1 by R into dou V by dou. 60 by R square into cos theta, A theta bar. And at the P, the given it is a 3 with theta is a 60 degrees and phi is a 45 degrees. Not the 45, I think it is a 25 degrees. Okay, there is no any phi. The 25 degrees is given the phi, and theta is a 60 degrees. So minus 120 sine 60 is a root 3 by 2. And cos 60 is a 1 by 2. Substitute these values and simplify. We'll get AR bar coefficient is a 3.849. And A theta bar is a coefficient is given, but we got 1.111 volts per meter. Got it, my students? Here directly, the previous example, the point is given in the Cartesian coordinate system. We are converting to the spherical coordinate system. But here directly given that the point is in the spherical only, theta and phi and R also. So we directly substituted those values in E bar is equal. And coming to the next example, if V is equal to 2x square y plus 20z minus 4 by x square plus y square volts, find the E electric field, D electric flux, and rho V volume charge density at the point given 6 minus 2.5 and 3. So the relation between the voltage and the electric field is a gradient of E bar is equal to minus del V. The given point is in the Cartesian coordinate system, and also the voltage is also in terms of the x, y, and the z only. So first of all, you can find the dou V by dou x. The first term 2y is a constant. For dou V by dou x, the 2y is a constant, x square is a 2x. The derivative. Minus 20z, minus 20z means plus 20 into 0. 20z is a constant, is a 0 here. We'll get second term is a 0. Minus 4 by the x square plus y square you have. The denominator having the x square plus y square. And you can write this as x square plus y square in terms of as of u1 by x square plus y square, the formula 1 by x square plus y square whole power 1. So that is x square plus y square whole power minus 1. So minus 1 into the derivative here, x square plus y square whole power minus 1 minus 1. And inside there is another one, there is x square is there, that is 2x. There is a derivative for this one, and the 2 minus 2x, and the denominator minus 1, we get it's a minus 2. So x square plus y square whole square will get. This is a derivative of 1 by x square plus y square. So you get the minus 2x by x square plus y square whole square. To simplify this one, you get 2y and 2x is a 4xy. 4xy here. And already the 4 is there, multiplying the term. The 4 into 1 x square plus y square is the denominator. So 4 2s, that is 8. 4 divided by x square plus y square whole square. That is a dou v by dou x. And the second is a dou v by dou y is equal to. In the first term, the 2x square is a common derivative of 1, y is a 1. And 20z is also a 0. And here the minus 4. The similar will get 2y by x square plus y square whole square. Since the previously that is a x term, here the y term. So that is equal to 2x square minus, already to get it is a minus is there, for 2 minus 2y and minus 2 is plus 8y by x square plus y square whole square. Dou v by dou x. So 2x square, 8y by x square plus y square whole square. And dou v by dou z is equal to. Dou v by dou z is equal to. The first term 0 and the last term is also 0. You get 20. 20 is equal. So E bar is equal to. Substitute this value 4xy plus 8xy, not the 8xy, 8x by x square plus y square whole square into ax. And 2x square plus 8y by x square plus y square whole square into ay bar, and 20 into az bar. Okay, simplify the term. At the point p is equal to, given p is equal to, what is the value they given? 6 minus 2.5 and 3. 6 minus 2.5 and 3, will get E bar is equal to, as of Ax bar coefficient is a 59.9, Ay bar coefficient is minus 71.9, and Az bar coefficient is a minus 2. And also they are asking that is a D bar also. D bar at P is E bar at the P into epsilon naught, because the relation between of D bar is epsilon naught into E bar. Multiply the epsilon naught to all the functions. What is the epsilon naught? 8.854 into the power of minus 12. You can multiply to get the Ax bar coefficient, Ay bar coefficient, and the Az coefficient. This Ax bar is a 0.53, and Ay is a 0.63, and Az is a 0.17 nanocoulomb per meter square. Okay, or ampere per meter. It is another unit of D bar is. And also they are asking to find the volume charge density also. So one of the Maxwell's equation we know del dot D bar is equal to rho v. You got the D bar, del dot D bar. So del dot D bar means del dot E bar is there. Dou by dou x of Ex and dou by dou y of I and dou by dou z into Ez. So dou by dou x, Ex term we will know, these are Ex term, my students. These are Ey terms and Ez terms. So without substituting the point P value, okay, del dot E bar is equal. Then simplify this equation according to that, and substitute the values of X is a 6, 6 is, Y is a minus 2.5, and Z is equal to 3. Del dot E bar is equal to be got. After that, to get the rho v, multiply the epsilon naught. Since we find here the del dot E bar, but rho v is the formula for the del dot B bar, not the B, sorry, del dot D bar. Okay, you can multiply the epsilon naught del dot E bar as is equal to del dot D bar over V. We got rho V is equal to 88.6193. This simply is a mathematical expression, my dear students. So with rho by dou x means you'll get the 4y as a first term, 4y. Second term, numerator having the x is there and denominator is also x is there. You can apply the u by v rule. Means first of all you can take the x square plus y square whole square and then you can apply the numerator derivative. 8x means 8 minus, keep the 8x is a common, it's a constant, apply for the derivative for the x square plus y square whole square. That is 2 into x square plus y square into 2x. Think what is the 4x into x square plus y square. Okay. In the same fashion, you can find the second term also, apply the u by v rule and simplify. You get the rho v is equal to 88.6194. Got it, my dear students? And the next one is next example. Till now we discuss gradient of V, that is a del dot E bar is equal to minus del V. And if it is a voltage is given, we are finding the E bar is equal to at the point whatever they given. Now go for the another example in the same way. For the given voltage V is equal to x minus y plus xy plus z volts, find the E bar at the point 1, 2, 4 and electrostatic energy stored in the cube of side 2 meters centered at the origin. They're asking another function is also there, the electrostatic energy stored. The first we can find the E bar is equal to minus del P. In the Cartesian coordinate system, given the point is at 1, 2, 4, dou V by dou x. So first of all, we can apply the derivative with respect to the x for the b, given 1 minus 0 plus y plus 0. So 1 plus y is a dou v by dou x. And dou v by dou y is equal. So 0 minus 1 plus x plus 0. So that is equal to 1 plus x or the minus 1 plus x. And dou v by dou z is equal to. So first term is a 0, second term is a 0, and third term is a 0, and fourth term is a 1. These are the values we have. And substituting this E bar is equal to minus dou v by dou x, nothing but 1 plus y ax bar, and x minus 1 ay bar, and 1 into az bar. We need to find the E bar at the point 1, 2, 4. Minus 1 is a x and 2 is a y, so 3ax bar, and 1 means 1 minus 1, you get the 0 here, the 0 ay bar plus az bar. Okay, now the E bar is equal to, multiply this function, the minus 3ax bar and minus az bar. There is a E bar at 1, 2, 4 for the given the voltage V is equal to volts per meter. Got it, my dear students? And also they are asking that the electrostatic energy stored, that is WE is equal to, the formulas we have, W energy stored 1 by 2 the volume integral. So actually that is a E bar dot df, d bar to d. And if it is a changes in terms of only the E bar dot d bar is epsilon naught into E bar dv. That is equal to 1 by 2 the volume integral magnitude of square E bar dot E bar into dv. Okay, or otherwise 1 by 2 epsilon naught is also there. Epsilon naught is the numerator. The denominator will get the epsilon naught, and it's the volume integral d square into d. Okay, because epsilon E bar is equal to d bar by the epsilon naught. D bar dot d bar is the magnitude square d bar, and denominator having the epsilon naught. So the three formulas we have. One is E bar dot d bar, another one is only in terms of E square, and one other term is only in the d square. I have the value of E bar is there, so I use 1 by 2 epsilon naught, the squared magnitude of E bar into d. dv means in terms of the Cartesian dx, dy, and the dz. So WE is equal to integral 1 by 2 integral volume integral epsilon naught E bar. What is the E bar here? 1 plus y ax bar plus x minus 1 ay bar plus az. You have to find the magnitude. Magnitude means ax bar coefficient square, ay bar coefficient square, and az bar coefficient square. Okay, the squared magnitude. Magnitude is only under root of. They're asking the squared magnitude. Squared magnitude means there is no any under root of. So 1 plus y whole square, x minus 1 whole square plus 1 square. Simplify these after the expanding 1 plus y square is 1 plus 2y into y square, and x square minus 2x plus 1 and 1. And we have the x square plus y square minus 2x plus 2y and plus 3, 1 plus 1 plus 1. So WE is equal to epsilon naught to the volume integral x square plus y square minus 2x plus 2y plus 3 into dx dy dz. So now apply the integration, the volume integral with epsilon naught by 2 as a constant with respect to the dx. Take the term as x square. The first, if I am applying the dx, the cube is the center of origin. You can use x square minus 2x into dx, and another one is the volume integral y square plus 2y into dy, and the 3 is a constant 3z dz. Okay, so then apply the integral for all these things. The cube is the center means 1 to 1, minus 1 to 1, minus 1 to 1, and the minus 1 to all the functions. With the dx, x square will get the x cube by 3, and y square, the y square is a constant, sorry, the y square is a constant, you will get the integral is nothing but y square into x, 2 x square by 2, and 2y is a constant into x, 3 into x with respect to the x value. Okay, we are applying here the integral, not the derivative. So, we'll take this one. Directly apply for the each one is with respect to the dy, and substitute the values of x values, and whatever the values you given the resultant value, apply the integral with respect to the y. So 2 by 3 into y, 2 into y cube by 3, and 4 into y square by 2, and 6 into y. Apply minus 1 and the plus 1 is the upper limit and the lower limit. And then after whatever the resultant value we have, 4 by 3 plus 4 by 3 plus 12. The 2 4 by 3, nothing but 8 by 3 plus 12. So 44 by 3 you will get, and the z minus 1 to 1, 88 epsilon naught 6. 88 epsilon naught 6 means epsilon naught is 8.854 into the power of minus 12. You can substitute and simplify. You will get that WE is equal to energy stored, electrostatic energy stored is equal to 0.12985 nano joules. Okay, this is one of the different example. And coming to the next one, point charges Q1 with 1 nanocoulombs, Q2 is minus 2 nanocoulombs, Q3 is 3 nanocoulombs, and Q4 is a minus 4 nanocoulomb are placed one by one in the same order, given the values at the origin and 100 and another one is a minus 00 minus 1 and 001 respectively. Calculate the energy in the system when all the charges are placed. Energy in the system. When the Q1 is placed in the work done is a 0, E bar is equal to 0. Okay, so what they told here, we already know that here when there is any Q1 is there, in the space there is no another Q1, there is no work done. If we bring that to Q2, there is a force is exerted on the Q1 due to the Q2, or the force is exerted on Q2 due to the Q1. Okay, that is nothing but when the Q2 is placed, there is a field of Q1 present. W2 is equal to Q2 into V21. V21, the potential will get due to the force is exerted on the Q2 due to the one charge. So Q2 into voltage Q1 by 4 pi epsilon naught R21. Okay, so R21, the value you can find out from the value R12 is a 1 only, the Q1 to the Q2. Q1, the Q2 is a 1 minus 0 and 0 minus 0 and 0 minus 0. The value is only the 1. Okay. So W3 will get, not the W3, W2 is equal. And W1 is a 0 because the Q1 is placed in the work, the work done is a 0. And similarly, the Q3, now we can bring the Q3 due to the Q1, there is a force is exerted on Q3 and the Q2 is also already there. So what is a W3 is equal to, there is a Q3, is a Q3, my dear students, Q3. The potential is V3 of 2 plus Q3, the V3 of 1. Got it, my dear students? So there is a force is exerted on the Q3 due to the Q1. A force is exerted on the Q3 due to the Q1 also. There's a Q3 is given 3 nano and Q3 is 3 nano with the voltage V32. V32 means the force is exerted on Q3 due to the Q2. So the voltage here, the R value is under root 2. Is under root 2. And there is a force is exerted on the Q3 due to the Q1. That R is a 1. Okay. Now we can substitute that values here. Q1 by the 4 pi epsilon naught is a 3.1. 3.1 value is a 1 and the 3.2 value is a root 2. The remaining all the functions is a common term. So Q1 and the Q2 and the Q3. Similarly, the last one, the Q4 is placed at their field due to the Q1, due to the Q2 and due to the Q3. All the force is exerted on Q4. So W4 is equal to the Q4 now the Q4 into the V41 and V42 and V43. Due to the charge 1 there is a work done and there is a charge 2 and where there is charge 2, 3 will get the forces exerted on the Q4. So now what is a R12? So Q4 due to the Q1 there is a distance is 1. Due to the Q2 the distance is under root 2. Due to the Q3 the distance is totally the value 1. So 1 root 2 1. So 1 root 2 and the R43 is there. The 2 that is 2 1 plus 1 will get there. Due to the Q4 here the 1 is there and here the 1 is there. So 1 plus 1. Otherwise you can find here the 0 minus 0 and 0 minus 0 minus 1 and the minus 1 whole square. So minus 1 minus 1 if you get it is 1 2 is there, minus 1 minus 2, 1 is a minus 2 whole square under root. So you'll get the 2 1. Got it, my students? So add all the terms to get the WE. W1 is a 0, W2, W3, and W4. W2 will get the minus 17.9, W3 will get the minus 11.1, and W4 will get the minus 39.035. Total is the work done. W is equal to minus 68.178 joules. If suppose if there is another Q5 is also there, Q5 into Q1 by 4 pi epsilon naught R, 5 with respect to the 1, and 5 with respect to the 2, and 5 with respect to the 3, and 5 with respect to the 4 also, there is a force is exerted due to all the charges already placed in the space. Okay. And coming to the next example, the potential field in free space is given. The V is equal to 50 by R. In the spherical coordinate system, R is varies from A to B. Show that the rho V is equal to 0 for the range of A to B. Find the energy stored in the region of A to B. So the given V, they are asking the potential. The potential is given, they are asking that E bar is equal to minus del V, we know. So dou V by dou R, 50 into 1 by R square. So 1 by R square, it again will get minus dou V by dou R is equal to 1 by R is nothing but minus 1 by R. Dou V by dou theta is a 0, and dou V by dou phi is also the 0. So E bar we got, and D bar is also we got. And energy stored, not the energy stored, show that the rho V is equal to 0. Del dot D bar is equal to rho V. So D bar we already got 50 epsilon by R square into AR bar. Dou by dou R of del dot D bar means we can apply the derivative with respect to the R only. The remaining all the terms is a 0. So what is that? 50 into 1 by R square. 1 by R square, the derivative 2 into R. 1 by R square is that dou by dou R of R square into 50. R square get cancelled, and 1 by R square dou V by dou R, that is any term, becomes a 0. So we prove that it is a rho V is equal to 0 with the range of R is A to B. And the last one, they are asking that to find the energy stored in the region A to B also. Energy stored, the formula is a 1 by 2 in terms of electric field epsilon naught E bar square. E bar is given 50 square by the R power 4. Why? We got the 50 by R square. Now it's a square term is 50 square by R power 4. So dV we know, dV is equal. So what is the dV? Why they wrote it is R square sine theta dr d theta d phi means it is a spherical coordinate system. The differential element is a dr and R into d theta and R sine theta d theta d phi. So totally you get the R square sine theta dr d theta d phi. And phi is varies from the 0 to 2 pi, and theta is varies from 0 to pi, and R they given A to B. Substitute that R square and 1 by R power 4 is there, 1 by R square integral will apply, and sine theta it is a minus cos theta, and phi is a phi. So 1 by R power 4, R power R square is a minus 1 by R, the upper limit is B and lower limit is a A. Simplify that one, we get 1.39 into the power of minus 7 into 1 by A minus 1 by B joules. Got it, madam?